right, we continue our study of percent in lesson 7.4, which introduces us to the percent equation. We have used proportions to solve percent problems. We have used decimals and fractions to solve percent problems. Now we're going to use equations, so we're getting more into the algebra part of this. Starts out with an example discussing astronomy. On June 14th, 2002, the distance between Earth and the moon, so here's Earth in the diagram and the moon here, the distance between Earth and the moon was about 375,000 kilometers. On that day, a traveling asteroid, here it is, missed Earth by about 32% of that distance meaning the 375,000 kilometers. The question is, how far away from the Earth was the asteroid at that time? We have used the proportion A over B equals P over 100 to solve percent problems. When we solve this proportion for A, that sounds kind of strange, but they're talking about solving this proportion for A and write P over 100 as P percent, you get the equation A equals P percent times B. Let's see how they did that. Over here, I'm going to rewrite our proportion. A over B equals P over 100. We're used to working with that proportion now. We're talking about solving the percent for A. That just means isolating A on one side of the equation. We've done that many times. The difference here is we're working with variables. But if you think about A as being divided by B in this proportion, A is being divided by B. And if we want to isolate A on one side of the equation, we could, strangely enough, we could multiply each side by B. We're just treating B as though it was a number. That would cancel B out over here, leaving A isolated equals P over 100 times B. We can't do the multiplication, so we just write times B. Now they're taking P over 100, which we know just means P percent, just like 3 over 100 would mean 3%. And bringing the rest of the equation down, this is what we call the percent equation. You can see it came from the percent proportion, and they're equivalent to each other. So it's just another way of solving percent problems. Let's see how we use this. So here's the percent equation. You can represent A is P percent of B. So we're just talking about any number is a percent of some other number using the equation A equals P percent times B, where A is a part of the base, B, that hasn't changed from our proportion, and P percent is the percent. Moving over to our note-taking guide, there we have it stated exactly the way we just saw it in our book. I'm not going to reread that to you. All right, let's look at example 1 back in our book. Finding a part of a base. To find how far away from Earth the asteroid was, as described above, we're going to use the percent equation. Our percent equation is A, that's the part. A equals P percent times B. B is the whole, just like it was in our proportion. Now they're starting to substitute things in there. We were given 32% in the problem. We were also given the whole distance between Earth and the moon, which was 375,000 kilometers. What we don't know is A. We don't know how far the asteroid is from the Earth, but we do know it was 32% of 35,000. Now, whenever we calculate in a percent equation situation, we change the percent, we rewrite the percent in its decimal form. So they have changed 32% into its decimal form, 0.32, moving the decimal point to the left twice, as we practiced earlier. And then they're multiplying 32 hundredths times 375,000. When you multiply those numbers, you get 120,000. Now that multiplication could be done on a calculator. It could also be done on paper using either lattice or traditional multiplication. but that's how they got their answer. I want to call your attention, oh, finally, so the answer is that the asteroid was about 120,000 kilometers away from the Earth. I wanted to call your attention briefly to the information on the side where it says reading algebra right over here. This is an important thing to keep in mind. We know that certain words can represent mathematical symbols. In the statement A is P% of B, the word is corresponds to the equal sign, and the word of corresponds to the multiplication symbol. We've heard that before. For example, we know 3 plus 5 is 8. Is a word that can be thought of as equals. We also have done things like 1/2 of 8 means 1/2 times 8. So we've heard those things before. They're just showing us how that corresponds to our new percent equation. All right, moving over to my note-taking guide, I'm going to do a similar example about finding a part of a base. In a newspaper survey, 1,100 adults were asked to name their favorite condiment. The most frequent response was ketchup, which was given by 47% of the adults. How many adults chose ketchup? So their solution to find out how many adults chose ketchup as their favorite condiment, use the percent equation. So they're going to start us out by rewriting the percent equation with the variables in it. A, the part, is equal to or is P%, some percent of or times B, which will be our base or the whole. They're going to substitute some things in. P% is the percent given in the problem, which was 47%. So we're going to put that in here, 47%. And we need to know what's the base, what's the whole. Now we know that all the adults in the survey, there were 1,100 of them. So that's the whole group of adults surveyed. So that's our base, or the B, within the equation. We also know that we're looking for 47% of 1,100. It's got to make sense within that context. All right, now they want us to write the percent as a decimal. We know that 47% can be written as 47 hundredths. If we don't remember that, we can think about our shortcut of moving a decimal point to the left twice. So we're going to do 47 hundredths times 1,100. All right, now we've got to do a little calculating. I think I'm going to forget about the decimal point for a little bit and do 47 times 1,100. But I'm also going to forget about the zeros. I'm just going to do 47 times 11 first. And I think I'm just going to use partial products. I know 47 times 10 would be 470. And 47 times 1 would be 47. So adding those together, I'm going to get 517. Now, I have to remember that this was 1,100. So when I multiply, I have to add 2 zeros on the end. So 47 times 1,100 is 51,700. Now I've got to remember I was multiplying by the decimal 47 hundredths, which has 2 decimal places in it. So moving those back into my product here, I'm getting the number 517. 517. So what does that mean? I just found A. A was the thing I was looking for. It was 47% of 1,100, 517. So the answer to the question is that the number of adults who chose ketchup as their favorite condiment was 517. Let's think if that makes sense. 47% is about 50%, a little less, isn't it? 50% would have been half the people in the survey. And if you look at the number of adults, it's pretty close to 1,000. So does it make sense that our 47% is pretty close to 500? It does make sense, doesn't it? So it's always good to think about that. Does the answer make sense? Now at this point, you may be ready to go ahead and try the checkpoint questions after example 1 in your note-taking guide. And if you are, go ahead. I'm just going to do a couple more examples, extra practice for those who need it. So I'm going to look at number 1. What number is 16% of 75? I'm going to go with my percent equation. Some number A is equal to some percent of B. I have a percent, so I'm going to put that in for 6p percent, 16%. I want to know what number is 16% of 75. So I know that 75 is the base. I'm trying to find 16% of or times 75. So I'm going to find A here. To do the computation, I have to change 16%, or rewrite it, I should say, in its decimal form. Now I can do the multiplication. So I think this time maybe I'll use the lattice. 75 times 16, forgetting about the decimal point for a minute, would look like this for some of us. 5, 7, 30, 42. I'm getting 1,200. So now I got to remember my decimal here. I was multiplying not by 16 but by 16 hundredths. 2 decimal places. So I've got to go back 2 decimal places and place my decimal point in there. So it looks like my product is 12. What does that mean? That means that 12 is 16% of 75. All right. Let's try the other one. What number is 89% of 110? So I'm going to start with my percent equation. A, the part, is p percent of B, the base, or the whole. And let's see, well, they're giving me a percent. 89% goes where p percent is. And I'm looking for what number is 89% of, 89%, that's a 9, not a 0, is it? 89% of 110. So I can hear that 89% of 110 is going to be 89% times 110. I'm looking for what number is 89% of 110. All right, changing 89% into its decimal form, multiplying by 110, I should be able to get an answer to that question. I'm going to do 89 times 110, but I'm going to forget about the 0 for a little while and just do 89 times 11, because I like to do that way. 89 times 10 would be 890, so I'm using partial products right now. 89 times the 1 would be 89. So adding all that up, let's see if I can get a little more space here. Adding that up, I'm going to get a 9 and a 17 and another 9. All right, now that was 89 times 11. I need to add 1 0 onto my product first. And now I need to consider the fact that I was multiplying by 89 hundredths, not 89. So I have to pull back 2 decimal places. It looks like I'm getting 97.9 as my product. Now let's go back and see, what does that mean? That means that 97.9 is 89% of 110. So that's what that means. All right, you should be able to go ahead and do your first 2 checkpoints for lesson 7.4.